in this lecture we'll see how to manipulate signals. So before we see how to manipulate them or how to manipulate using equations and models, we'll just see some examples. Okay, so we can motivate ourselves about why we need manipulation by looking at some audio signals. So this is an app with which we can record audios. Let me record something. Hello, let's understand how to manipulate signals today. Okay. Now I've recorded an audio signal. Now sometimes you can listen to videos at twice the speed or half the speed. I know many would watch lectures like that, or probably watch YouTube videos at half the speed or at twice the speed or 3 times the speed and so on. So essentially what we are doing, we are manipulating the signal. So we are either compressing or expanding the signal. Now let's say I want to expand this signal. Okay, basically if I want to listen in 2 seconds, it means I want to hear it much faster, right? So that means I have to increase it, let's say by 2.5. So then now the signal has been compressed from 5 seconds to something smaller. So right, so it sounds very weird. So the same thing we can now expand. So we have compressed. Now using the same tool we can also expand it. Right. So let's say now I want to hear it at 10 seconds. Now this entire signal has expanded to 10 seconds. Right. So it sounds weird, see? So we can play with this expanding and compressing the signal. So basically expanding is nothing but slowing down the signal, and compressing means it's speeding that up. So these are all manipulations of the signals. You can even delay when it starts. Now it is starting at, let's say at this point it's starting at 1 second or little before 1 second. Now I can delay that. I can just take that out and then introduce some delay to it. Like, so I can say delay it by some amount. So what is how much seconds delay? So I have to introduce delay. So let's say I have delayed by some 2.7 seconds. So if you observe here, then what happens? There is a delay that is introduced. So it started at 1 second, now it is starting much later. So we are just manipulating signals here by starting it with some delay, or we are compressing it, we are expanding it. Now this is nice to visualize using those audio signals. Now how do we model this? Remember, in order to do analysis, we need models. So that is what we'll understand in this lecture. The first thing is what we'll call as time shifting. Basically it is delaying. So we are just giving fancy names to these operations, delaying and then speeding up operations. We'll give fancy names. The first fancy name is time shifting. Basically what this means, now if you have a signal which is our good old rectangular signal, okay, it starts at -half, goes to +half in time. Now if I want to delay this, then let's say I want to delay this by 1 second. So instead of starting at -half second, I want to start at half a second. That is delaying it by 1 second. Now a delayed rectangular function will now look like this. It will start at 1 and then end at 2 seconds. Okay, but how do I represent it mathematically, or how do I analytically represent? What is the model for this? So the model for this is the rectangular function. This is the plain old rectangular function. The rectangular function, something that starts a little later. So it starts later by 1 second. So we'll subtract 1 from this. So what do we mean by this? So the time here when t is equal to -half, it started earlier, right? Now we are adjusting that independent variable's value so that the function will start a little later. So what is the value of the function when t is -half? We know that is when it is 1. So the rectangular function of -half will be 1. Now when this -half is attained, that is what we are trying to control. So when t is -half, we know that it will start becoming 1. So why don't we contain the value, or why don't we adjust this value, or why don't we manipulate this value so that we'll get to have the signal start at exactly where we want it to start. So if we want to start it at 1 second, how do we represent it? We'll represent it such that this value is minus half, but then that value will be minus half only when t is at half a second, right? So this is half a second, this is 1 half. So that is by subtracting whatever value t takes, t with minus 1. So when t is equal to half, at t is half, what is the value of t minus 1? It is minus half. Okay. So the rectangular function starts at t is equal to half instead of starting at t is equal to minus half. In other words, we can shift it to any point we want. Let's say we want to start this as 10 seconds, okay, and then end at 11 seconds. What should be the corresponding time shift then we have to give here? Then we want to ensure that 10 minus something is equal to minus half. That is the starting point, remember. So which means this shift should be equal to 10 plus half. Okay. So when you want to represent this shifted signal, you can say that t minus 10.5. So if you have this as t minus 10.5, it means that we have shifted the signal to the right. In other words, we have delayed it. So something that has to start at minus half a second, we have delayed it to start at 10 seconds. And this corresponds to subtracting some value from the independent variable. So if you subtract some value from the independent variable, what you have done is you have essentially delayed the signal. And graphically, how does this look like? In the plot, it will move to the right. So delaying a signal is equivalent to moving to the right in the plot, and it is equivalent to subtracting some positive value in the equation. So this is what is called as time shifting when you want to delay. Okay, so this is about delaying. Now if I want to advance the signal, what if I want to hear this audio signal much earlier? What if I want to see this rectangular function much earlier? Instead of starting at minus half, I want it to start at, let's say, minus 3 seconds. So I want something which looks entirely in the negative time. Okay, start at minus 3 seconds and at minus 2 seconds, which means I want to advance it. So now what do we want? We want something such that at t is equal to minus 3, that is some t value minus 3, we'll have to have something. Let's say we'll do the same operation and see what happens to it. At minus t, we want to see half. So remember, the starting point of the function is at minus half, and we are saying that the starting point should now move to minus 3, okay, which means we are doing something to the dependent variable. We are manipulating the dependent variable so that this minus 3 becomes minus half. So this manipulation is by adding or subtracting something. So we are doing this operation. So then what should be the corresponding value of t? You can see that the corresponding value of t should be now equal to minus 2.5. Okay, so you are subtracting here. Okay, so which means t minus of minus 2.5, or in other words, t plus 2.5. So if you do t plus 2.5, then what you have done is you have advanced it. Or in other words, if you just plug in a minus here, then you will see that it will become plus. So when you add a particular amount of value to the independent variable, the signal starts getting advanced. So if you add a positive value in this representation, remember we have two representations. One is this equation. Basically, this is what we'll call as the analytical or mathematical representation. The other one is the graphical representation. So if you want to speed up the signal, if you want to delay the signal, then what are you doing? Basically, graphically, you are moving it to the right, okay? And analytically, what you're doing, you are subtracting some value. And if you want to, let's say, advance the signal, then what are we graphically doing? We are graphically moving it to the left. And this moving to the left, how does it look analytically? It's just adding some quantity. Okay? So there are two representations, analytical and graphical, and they correspond to what happens either in delay or advancing. So delaying is just moving to the right by subtracting something, and advancing is just moving to the left by adding a positive quantity. Now, where do we see this in practice? We just already saw earlier, let's say we want to model the signals that are flowing in a USB port or a serial port. Often it appears in very different scenarios. So you might have seen TV transmissions. Let's say you had a satellite connection and then you are watching a match. It might so happen that you would see the match uh, signals coming in your phone much earlier than in your TV. So there might be a delay that you see in your TV of, let's say, 2-3 seconds. That's because the time taken for the signal to travel to the satellite and come back is so long that there is a delay introduced, and then that delay you can model something like moving the signal to the right graphically and subtracting some value in time analytically. And just like how we saw in audio timing, we can just make some signals appear faster. So if I speak something now, if I record it, and then I say that, okay, this word should come much earlier. What do we do in audio? Like we saw in the Audacity app, you just move it in the app, right? So you just cut the signal, put it in front or later. Essentially what you're doing, you're delaying or advancing, which is nothing but moving it to the left or right, which we represent analytically using these two quantities. Okay. This is what we call as time shifting. Okay. Now, can we compress or expand the signal? We'll have a fancy name for that. We'll call as time scaling, which we'll see next. Okay. Let's see some more examples of time shifting. So, we had some basic functions earlier, right? And that function was the step function, ramp function, rectangular function, and the sinusoid. So, if you shift the step function, what you have? So, our vanilla step function looks like 0 till time t is equal to 0 and then 1 after that. Now, let's say we delay it. How do we delay it? Graphically, we move it to the right. Let's say we delay it by 2 seconds. Okay. And how do we represent this mathematically? Mathematically, we have to say that by delaying is equivalent to subtracting some amount, which means u of t minus 2 is equivalent to delaying it or moving it to the right. Now, how do we advance this? Let's say we want to advance this, and let's say we are advancing this by 3 seconds, which means at minus 3 itself, I need to start saying this function. So, graphically, this is how you represent it. But analytically, how do you represent it? You have t plus 3. Now, if you have a ramp, how do you represent it graphically? This is a regular ramp without any manipulation. Okay. Now, let's say we want to delay it. Let's say we delay it by 1 second. How do we delay it by 1 second? We just move it to the right. So, the signal starts at t is equal to 1 second. Now, how does this look like analytically? You have r of t minus 1. So, anything that moves to the right, anything that gets delayed gets a negative value in the time. Okay. So, this is how similarly you can see what happens to a sinusoid. So, let's say you have a sinusoid, a cos that extends on both sides. Let's say this is cos 2 pi t. Now, let's say I want to advance it, okay, which means it has to move to the left. So, let's say this signal comes earlier, something like this. Okay. Now, how does it look like analytically? It looks like 2 pi t plus some value. It can be, let's say, pi. Okay. So, in other words, keep in mind, all we have to do is either move left or right by just adding or subtracting values. Okay. So this is what we refer to as delaying or advancing. Now let's take a little weird example. So we know what are these regular standard functions, the step function, ramp function, rectangular cost function. But what if we have an arbitrary signal which looks like this, okay, where the signal looks something weird as time proceeds, it goes up and down and then remains zero everywhere else. Now what if I want to move this signal? Let's say I want to move this to the right. I want to move such that the signal looks like this. The signal is starting at -2 seconds. Now let's say I want to start it at 2 seconds and then proceed whatever it looks like as such. So we have delayed it, which means we have moved it to the right. Now, which means the signal has to be having a negative value that is coming here in the dependent variable. So what should be the appropriate negative value? So the signal actually started at -2 and then now we are moving the starting point to +2. So which means, let's say we have some capital T here. So at t equals 2, we are supposed to see that t minus capital T should be equal to -2. So the starting point, which was earlier at -2, should come at 2, which means at time value equal to 2, we are supposed to get -2. Then what is the appropriate value of delay that we should add? From this equation, we can get that this capital T should be nothing but -2, which is equal to 4. So if we just plug in 4 here, what we have done is we have effectively shifted the signal by 4 seconds. Whatever started at -2 now is starting at +2. So you can see the same thing happening even at 0. So we had the signal to take this particular value, which is 1, at time t is equal to 0. Now after shifting, what happens? It is taking that same value at time t is equal to 4. In other words, we can do the same calculation. At t is equal to 4, we have t minus capital T to be equal to 0, which is, let's substitute the value of small t, and 4 minus t, this is equal to 0, which implies the same thing, t is equal to 4. So every point that is appearing in the signal, you can take any point, here. So you will have the corresponding value of t here and the corresponding value of x of t there, right? Now what are we saying here? The new value of t, let's say this corresponding point, this point in the signal should appear here. Then there is a new value t naught. Then all we are saying is at t naught, we want t naught minus t to be equal to this corresponding, let's say this is t1, this t1. From this equation, we can say that the value that we are looking for is equal to t naught minus t1. And from this, you can compute what should be the delay, or what should be the signal that, what should be the value of time that you have to subtract or add in order to cause the delay or in order to cause the advancement.